Hi, this is Walter Stone, and we are in Unit 7. This is Lesson 3 on complex rational expressions. And after this lesson, you should be able to simplify these types of complex rational expressions. So we're going to take techniques we've learned from simplifying, multiplying, dividing, and adding and subtracting rational expressions and applying them here in this lesson. So practicing these, you will practice a lot of the skills that you've learned up to now with these rational expressions. So one thing to think about is, what is a complex rational expression? Well, it's one that has a rational expression in the numerator or denominator or both. So here in this first expression, we have a 1/3 in the denominator. So since we have this fraction in a denominator, it's a complex rational expression. Here in both the numerators and denominators, we have fractions. So this is a complex rational expression as well. So what we want to be able to do is simplify these. So we'll take a look at some complex rational expressions and we'll learn how to simplify them. So here we want to simplify 1 plus 1 over x over 1 minus 1 over x squared. And simplifying gets these to a regular simplified fraction where we just have a numerator and a denominator with no fractions in them. And one way to look at this is to simplify the numerator by adding these two expressions, simplifying the denominator by doing this difference, and then do the division of the numerator by the denominator. So this fraction bar means division. We're going to divide the numerator by the denominator. So just kind of looking ahead at this type of way of doing things. So in the numerator, we have a common denominator, a least common denominator of x. So if I multiply the first fraction by x over x, I get x over x plus 1 over x. In the denominator, we have a least common denominator of x squared. So I need to multiply the first number here by x squared over x squared. So 1 times x squared over x squared will be x squared over x squared minus 1 over x squared. So the numerator will simplify to x plus 1 over x, and the denominator will simplify to x squared minus 1 over x squared. So this fraction bar means division. We're going to divide the fraction in the numerator by the fraction in the denominator. And we learned that when we divide fractions, we multiply by the reciprocal of the second fraction. So we have x plus 1 over x times x squared over x squared minus 1. And we learned that when we multiply fractions, if we can factor and find any common factors to cancel out, we can simplify. So we have x squared times x plus 1 over x times x plus 1 times x minus 1. X squared, the x plus 1's cancel, and x squared divided by x is x. So we'll have a factor of x left in the numerator over x minus 1 in the denominator, and that will be the simplified version of this fraction. Another way to do this, method 2, is we multiply both the numerator and denominator by the LCD of both denominators. So when I look at x and x squared, we would have a least common denominator of x squared. So I multiply the numerator and denominator by that LCD, and I distribute. So to get this numerator, I took x squared times 1, which is x squared. X squared times 1 over x will have a factor of x that cancels, and I'll have x. In the denominator, x squared times 1 is x squared. Then x squared times 1 over x squared, the x squareds will cancel, and I'll get minus 1. I have a common factor of x in the numerator, so we can write that as x times x plus 1. In the denominator, x squared minus 1 factors to x plus 1 times x minus 1. So we have a common factor of x plus 1 that can cancel, and we'll be left with x over x minus 1. So we see that both methods give us the same answer. And many students use method 2 as their method of choice. It's good to know both methods, but I also agree that method 2 is a little bit easier. It goes a bit quicker. And it's also a similar method as to when we solve equations in the next lesson that have rational expressions. So I think this type of method, the multiplying by the LCD method, is really good to use, and it's quite easy to use. So try method 2 on working with this fraction. Pause the video and then come back and take a look at and see if we have the same answer. Okay, so I looked at these fractions and I saw that 3 times x would be the least common denominator. So I multiplied both the numerator complex fraction by the denominator complex fraction, the numerator and denominator of this complex fraction by 3x. So when I multiply, I distribute the 3x to both terms. I make sure to do that. 3x times 1 over x, the x's will cancel. 3 times 1 gives me 3. 3x times 2 over 3, the 3's will cancel, and I'll have minus 2x. And then in the denominator, 3x times 1 over x, the x's will cancel. 3 times 1 is 3. 3x times 4 over 3, the 3's will cancel, and I'll get 4x. So this method works really nicely to get us down to a simplified fraction of 3 minus 2x over 3 plus 4x. Here's another one to try. Pause the video, try this one out. And this is a little bit of something you'll see in pre-calc and calculus later on when we add an h here, where h is a constant. This could be like h plus 1 over h, or h plus x plus 5, and so on. So in the denominator, we only have h. So what we can assume is that the denominator in the of this fraction will be 1. So for the LCD, you'll need x times x plus h times 1, or x times x plus h. So try working with that idea, and then compare your work with my work. Okay, welcome back. So I did what I told you to do. I found that x times x plus h is the least common denominator. I multiplied that to both the numerator and denominator of the complex fraction. And what happens when I multiply the x times x plus h by 1 over x, the x's cancel, and I get x plus h. And when I multiply x times x plus h by negative 1 over x plus h, the x plus h's cancel, and I get minus x. So what happens is x minus x is 0 plus h. I get an h in the numerator over this x times x plus h times h. So these h factors cancel, and I get 1 over x times x plus h. Okay, so that's another example that kind of, we use this type of procedure later in calculus, and you'll work with that. Okay, so try the written practice exercises on this learning guide, do the online work, and we will see you in class. Take care.